Today, we're going to pull back the curtain on one of science's most essential but, often hidden processes, peer review. It's kind of like the gatekeeper of scientific knowledge, the quality control system that separates the really groundbreaking research from flawed ideas. So let's dive in and see how it really works.
It all really starts with this one big question. In a world that is just flooded with information, how do we make sure that the science guiding our health, our technology, our whole understanding of the universe is, reliable? The answer lies in this really rigorous process of expert scrutiny.
And that process is, you guessed it, peer review. It's a system where fellow experts, your peers, in any given field basically vet new research. They check the methods, they challenge the conclusions, and ultimately they decide if it's solid enough to actually be published and shared with the rest of the world.
Right, so the whole goal here, the entire point of peer review, is to uphold the integrity of the scientific record. It's about making sure that what gets published isn't just interesting, but that it's also rigorous and genuinely impactful.
A peer reviewer really wears three different hats. First, you're a detective, evaluating if the research is even valid. Then you're a coach, guiding the authors on how to make their work stronger. And finally, you're an advisor, helping the journal editor decide whether to publish it or not. It's a huge responsibility.
So how does a great review actually get started? Well, it's not just about pointing out all the flaws. It begins long before you even write a single word of feedback. It all starts with having the right mindset.
Okay, just imagine this. An email lands in your inbox. You're the expert, and a journal is asking for your opinion on a brand new study. That can feel pretty daunting, right? So what's the first practical step you should take? Where do you even begin?
Well, experts recommend something called the two-pass method. The first time you read it, it's all about the big picture. What was the goal here? What did they find? You don't want to get bogged down in all the little details. Then, on that second read, you put on your detective hat and you dive deep, looking at every single section with a really critical eye.
Now this is probably the most important part of the reviewer mindset. It's the golden rule of peer review. You're not just critiquing, you're having a professional conversation with a colleague. And honestly, this simple idea changes everything about the tone of a review. So, the crucial takeaway here is to always be respectful. Unprofessional or overly harsh reviews, they just undermine the whole process. The goal is to build up the science, not tear down the scientist. Your feedback absolutely has to be constructive and fair. Okay, so you've got the right mindset. Now let's get practical and look at how that translates into the actual structure of the review itself. A great review isn't just some random list of complaints. It's a well-organized document that's designed to be as helpful as possible. Journal editors absolutely loved this structure because it's just incredibly clear. You start with a summary to show you actually understood the paper. Then you highlight what's good about it before diving into the weaknesses. And finally, you separate the big, must-fix issues from the smaller, minor suggestions. This organizes everything perfectly for both the author and the editor. This comparison really gets to the heart of what makes feedback useful. On the left, you've got this totally unhelpful comment. The author's conclusions are incorrect. What do you do with that? It's a dead end. But look at the one on the right. It tells you the exact location, it explains why the conclusion is unsupported, and it offers a specific, actionable suggestion. Game changer.
So that's the formula, right there. It's depersonalized. It's all about the content, not the author. It gives you crystal clear reasoning, and most importantly, it gives the author a clear path forward. That is the huge difference between just criticism and actual constructive feedback.
This brings us to a really key distinction. A reviewer is chosen for their expertise in a specific subject, and their job is to focus on the big scientific questions, not all the little stuff. Let's be super clear about this. A peer reviewer is not a copy editor. Sure, you can make a note if a paper is just poorly written overall, but your main mission is not to fix typos or grammatical errors. The journal has a whole team for that. Your focus has to be on the science. So what are those big questions you should be asking? Well, first up, is it new? Does this research actually offer something new to the conversation? Even if it's just a small step forward, does it build on what we already know? Next question, is it important? A study can be perfectly done, but if it doesn't tackle a meaningful question or fill a real gap in our understanding, it might not be worth publishing, at least not in a top journal.
Then comes rigor, and this is where your expertise is absolutely critical. Are the methods the right ones for the question they're asking? Is the data analysis sound? Could you, at least in theory, reproduce these results? This is the very foundation of scientific validity.
And finally, you have to ask about impact. Especially in fields like medicine, a key question is, can this research actually be translated into practice? Is it going to change how doctors treat patients or how other scientists approach a problem?
So, after all that, why does this effort matter so much? Well, a great review does way more than just improve one paper. It creates a ripple effect across the entire scientific community.
Think about it. A good review upholds scientific integrity. It directly makes the final paper better. It helps editors make more confident decisions. And that can advance an entire field, maybe even leading to better patient care. And hey, as a bonus, being a great reviewer sharpens your own critical thinking and makes you a better scientist too.
This quote just sums it all up perfectly. In an age of instant communication and just endless information, this careful, expert evaluation process is more important than it has ever been. It's the bedrock of quality and trust in science.
So, we'll end on this thought. The principles of a great peer review, being specific, constructive, and respectful, they aren't just for scientists. They're for anyone who gives feedback to anyone else. The goal should always be to build things up, not just tear them down. So how can you use that idea in your own work?